Now, in the last class we have discussed about state space model, right? Now, we'll see what are the different form of system matrix we'll get. So here we have 4 form of system matrix which is obtained from the state model. Now let's describe this form. In the upper part of the matrix, the diagonal element are unity and the lower row consists of negative coefficient of the characteristic polynomial equation, or the lower part of the matrix contain diagonal element as unity and the upper row contain the negative coefficient of the polynomial equation. Then this two form is called as controllable canonical form. Okay, and if the first column contain negative coefficient of the polynomial equation and the diagonal element contain unity, and in this form if the last column contain the negative coefficient of the polynomial equation and the lower part of the matrix contain all the diagonal element of the lower part of the matrix contain unity, then we can call this as observable canonical form. Okay, so this two equation is observable canonical form and this is controllable canonical form. Okay, I'll put it here. Okay, so let's solve a question and determine the system matrix as controllable canonical form. Now let's solve your question. So in this question we don't have any derivative in the right side of the equation. Whatever the derivative we have, that is in the left side of the equation. So first we'll let our space variable or state space variable. So let y of t is x1. Okay, so what will be the differentiation of y of t? That will be x2. Okay, which is nothing but differentiation of x1. So this is x2. And what will be the double differentiation of y of t? Divided by dt square. So this will be differentiation of x2, right? So this is x3. Now we'll write the equation triple differentiation of y of t by dt cube in terms of x1, x2 and x3. Okay, so this will be equal to minus 7 d square y of t by dt square plus, sorry, okay, I'll write this from minus 3 first. Okay, from x1. So this will be minus 3 y of t minus 5 differentiation of y of t minus 7 double differentiation of y of t plus 10 u of t. Now what we can write at this place? Can we write differentiation of x3, right? Because x3 is double differentiation of y2. Now minus 3, what is y of t? That is x1. Minus 5, this will be x2. Minus 7, this will be x3 plus 10 u of t. Now we will write this equation in matrix form. So these are the differentiation of a state variable, right? x1, x2 and x3 dash. This is equal to this will be x1, x2, x3. Okay, so what is x1 dash, that is x2, right? So we can write this as 0 1 0, okay, because x1 dash is x2. Okay, so this two term will be equal to 0. Now what is x2 dash? X2 dash is x3, so x1 and x2 will be equal to 0, so this 2 will be equal to 0 and this will be 1. Now what is x3 dash? X3 dash is minus 3x1 minus 5x2 minus 7x3 plus 10 u of t, right? So this two term will be equal to 0. Similarly, what is y of t? That is x1, so y will be equal to, that is x1, right? So this will be 1 0 0 x1 x2 x3. Okay, so this is actually state space model is in controllable canonical form. So the above state space equation, the state space model is in controllable canonical form. Okay, sorry, this will be okay.